Okay, so our next speaker is Regina Nuzzo. She's going to be talking about brain hacking stats communication, a quick tour. Regina is a freelance science writer and professor in Washington, D.C. After studying engineering as an undergraduate, she earned her PhD in statistics from Stanford University. Currently, she's teaching statistics in American Sign Language at Gallaudet University, the world's only liberal arts college for deaf and hard of hearing students. Dr. Nuzzo is also a graduate of the Science Communications program at the University of California-Santa Cruz. Her science journalism specialty centered around data, probability, statistics, and the research process. Her work has appeared in Nature, Los Angeles Times, New York Times, Reader's Digest, all over the place. So statisticians know you well, Regina. You're like our most well-known a reporter, not reporter, a journalist in the statistics world. So we're very happy to have you speaking today. Thank you for your participation.
Thanks so much for that great introduction. All right, I'm going to go ahead and share my screen. Got it? Yes, all right, great to be here. Thank you. Before you begin, by way of introduction, I want to share a brief story about myself. I am a cyborg, not exactly like this kind, more like this kind. I was born half deaf, and with each passing year, it got a little worse and technology got a little better until finally it was just too much. I wanted to hear birds for the first time ever. So 5 years ago, I got a cochlear implant in one ear, and I had really high hopes. I was going to be Jamie Summers running in the field. Everything was going to be perfect. My brain was going to be great. I was smart. I would just tell my brain what to do, and it would automatically work. It would just automatically do it. And reality was more like this. Unbelievably hard, the hardest thing I've ever had to do. The problem was that my brain at first literally did not recognize the signals that were coming in as sounds. They were coming in as colors or textures or sensation, not sound. I had synesthesia. My brain had rewired in all those years of deafness. So what did I do? I tried harder. I tried to force my brain. I tried to ignore the signals that I was getting, and I fixated on what I was supposed to be hearing. I wasn't hearing it, but I was supposed to be no good. I ended up feeling like I was desperately pulling on my brain's door. It refused to open. And then I had to figure out, I had to change my approach. I had to somehow get in. So in order to learn to hear, in order to understand these strange signals that I was getting, I had to hack my brain. I had to learn to work with this hunk of gray matter that I had, not the brain that I wished that I had or imagined I'd had. And if birds were feeling like bright silver needles through my brain, that's what they were, and they weren't coming through a sound, then I decided, okay, that's what I'm going to do. I am going to work with whatever I have. So why am I telling you this? This year, to be honest, it feels a little the same. 2020, so much vital quantitative information, and it's just so complicated, it's hard, and it keeps on coming. It will not stop. And sometimes it feels like the brain's doors are locked, nothing's getting in. So today, what I'd like to suggest is that in order to communicate complicated quantitative information, let's hack our brains. Let's fit the data to the brain that we have, not the brain that we want. With apologies to Donald Rumsfeld, who had a similar sort of quote. So in the years that I've been thinking about communicating statistics, talking about it, figuring out the best ways to do it, I've come up with 5 personal pillars for how I like to approach quantitative communication. And today I'd like to talk about two of them, numbers and uncertainty. First up, numbers. So our sense of numerosity is extremely old. And I was shocked to discover that the words for 1, 2, and 3, those sounds 1, 2, and 3, are amazingly similar across all languages, even more similar than the words for mother and father, which is amazing. And it's likely that Neanderthals 15,000 years ago were using similar sounding words as 1, 2, and 3 to refer to these quantities. And this is amazing. It just shows how important numbers are to us and how important it is for us to clearly think about and communicate these numbers to others. So if that's true, how can we explain graphics like this one? I don't need to explain it. You can see that right off the bat, right? How can we explain this? If numerosity is so deeply embedded, how do we get something like this? And I don't think that we can even blame COVID brain on this one. Until you realize that percentages are one step removed from our physical environment of actual things, this embodied quantification. And studies suggest that at some level, our first reaction to percentages when we see these numbers is not to see them as parts of a whole, it's to try to count them. Brains like things they can count. We don't do as well with proportions. So I'd like to give you an example of that first step. These are results from a paper in July, came out in July, that looked at mortality rates from COVID across the world, different states. And part of what they found, I pulled out here, Massachusetts. So as of May 24th, from when COVID first appeared in the state, about 92% of COVID-19 deaths were age 65 or older. So I don't know about you, but it's not immediately clear to my brain what I can do with this. Okay, I've got 92%, so that's 92 out of 100 seniors died of COVID? Well, of course not. That's not 92%. What do I do with this? Even if I add the information, about 17% of the state population was 65 or older. Okay, we're getting there, not quite. What about if I give you percentages? By the end of May, 0.0092% of people under 65 in Massachusetts had caught COVID-19 and died, compared with 0.48%. At least this way we have some base rates going on, but I feel like this isn't quite giving me enough. What about natural frequencies? For every million people under 65 in Massachusetts, about 92 had caught COVID and died by the end of May, compared to about 4,800 who were age 65 and older. Okay, now we're getting somewhere. Is there a benefit to a smaller denominator? For every 10,000 people under 65, about 1 had caught COVID and died, compared to about 48 who were 65 and older. So this is getting better. So there's research that shows we prefer these natural frequencies. We can more easily picture the people and picture the deaths in a way that percentages don't give us. And if we like things visually, this is a very low-tech graphic of what happens if we put everyone in stadiums. People younger in the top stadium, and here we see in red the people who had died in the stadium full of older people. Is there a benefit for tribe-sized denominators? What if we take it down? For every 1,000 people under 65 in Massachusetts, fewer than 1 had caught COVID-19 and died by the end of May, compared with about 5 who were age 65 and older. So the nice thing about the tribe-sized denominator, some research suggests that we do better when those denominators are closer to things that correlate with what we could more easily picture. It's easier to picture 1,000 people than 10,000 people. And this corresponds with the sort of tribe environment for early humans. And this is what we were to look like if we were to put them into theaters. Okay, next up, uncertainty. Formal probability, unlike numbers, the human brain hates uncertainty. It hates probability. We didn't have formal mathematical approach to probability until about the 16th or 17th centuries. And you can see this in our language. Whoops. We toss around these words like chance, probability, confidence, plausibility. They're all the same thing. Our language hasn't caught up to this. It doesn't help us separate the different types of uncertainty in the world. And there are two different types of uncertainty. Well, there are many types, two big ones. We can talk about knowledge and our personal uncertainty, confidence. This has its roots in the legal system. Or we can talk about randomness, this universal risk that randomness, predicting the future, has its roots in probability theory. Why are we using the same word to describe all of these? We can see that our brains hate uncertainty so much. This is a quote from a COVID-19 researcher during a webinar. He was responding to concerns about some estimates, and people were concerned about the uncertainty bounds, the confidence intervals around that. And he was saying, you know, a lot of the concerns, it was just the uncertainty bounds. The uncertainty is the uncertainty. It's not the final answer, he said. And I feel like, is there a good response to this? I would turn to Voltaire. He said, doubt is not a pleasant condition, but certainty is an absurd one. And for me, this means any answer that implies complete certainty without framing the answer within uncertainty, that's just absurdity, that we're not going to get anywhere there. And that leads to a great quote by Daniel Kahneman. No one ever made a decision because of a number. They need a story. So making a decision implies there's some uncertainty there. Otherwise, we wouldn't be making a decision. The one way that we can deal with this is through a story. So can we use this to talk about what we talked about before? So the risk of catching COVID-19 and dying from it between mid-March to late May in Massachusetts has the same added risk as skydiving. So for people in Massachusetts that were 65 and younger, going skydiving once every 3 weeks, the same equivalent risk there. For 65 and older, their risk would be the same as if they were going skydiving 10 times a day for 2.5 months. Or for those under 65 commuting by car from Springfield, Massachusetts to New York every day, about 330 miles round trip. For people 65 and older, their risk was like they were commuting by motorcycle from Framingham to New York, which is about 420 miles. And if you like history, for the younger people, this is equivalent to being in the air over Germany in a World War II Royal Air Force UK bombing mission for 1 second. Same kind of risk. This is for young people. For older people, their risk of catching and dying of COVID during that time is equivalent to them being up in the air for 1 minute. Now, you may have found this surprising, putting it together, all the numbers. I found it surprising. Luckily, this is good for us. Organisms only learn when events violate their expectations. And just in time for 2020, right? One good thing in all this, we are paying attention. Our expectations have been violated left and right. So I'll say when we do stats communication, let's talk cleverly, creatively, humanly to the brains that we have, not the brains we wish we had. We'll get much further that way. And I say from a personal note that yes, after hacking my brain, I can now hear birds singing, and it's just as amazing as I had imagined. Thanks very much.
Thank you. Great talk. All right, this time we have about 4 minutes for questions. So if anybody wants to put one on the chat, I'll try to read it and ask. In the meantime, I'll ask a couple myself. So I have experienced this firsthand often, the problem with people understanding percentages and uncertainty even more. So one of the examples you were giving, do you find that those help like, I mean, how do we know that they actually help people understand? Like, I don't for them to work, do you have to kind of know how likely it is, how dangerous it is to ride a motorcycle to New York, for one. But
Right.
I don't know. Do you have any
Right.
information, data on that?
Right. Great question. So this comes from a lot of work that David Spiegelhalter has done on micromorts. And you're right, I condensed it a little bit for this talk. One micromort is 1 in a million chance of dying. And that's the same risk that we generally in the US take on a day-to-day basis, risk of dying from injury or accident. So you're right, it doesn't quantify it, but I feel like it helps us make it relative. So I'm looking at this, I'm thinking about the people I know, friends and family that are 65 and older. Would I want them to go skydiving 10 times a day? Not so sure, right? Would I want them going by motorcycle 400 miles, whatever it is? I would feel comfortable with my risk under 65. I would be worried about their risk. This is what I mean, getting into a human way. It gets to us in a sort of gut sense, in addition to the numbers.
So is there a table that we can look up somewhere where you have what's 1 in 10, what's 1 in 20, what's 1 in 100? Like to communicate?
That's a great suggestion. I should do that. I don't know of a table right now. It requires having to go back and do the work yourself, but it might be a good value for journalists, right? To come up with something like this so we can have these equivalent human-centered scales and units.
Make sure to call it the Rafa Centered Scale Table. TM. All right, so there's some questions from the audience. Great presentation. How would you suggest we move the needle in changing our language in peer-reviewed journals and studies to make them more accessible and less focused around p-values and confidence interval? This comes from Lauren Kunz.
Lauren is asking a question near and dear to my heart. I think that part of it might come from changing the culture around researchers and statisticians especially, and teaching them these tricks of communication. And I see a lot of statisticians blaming the users, saying we need to teach other people, we need to give them more stats classes, and that will solve the problem. I say, no, let's take it on us. It's easier to shape the information than it is to shape people's brains. And to do that, we can start with changing the culture and apparently the scale that you and I are going to make millions off of.
All right, so the next question from Andrew Refkin. Bravo, Regina, amazing insights. Notably, in a New Yorker's podcast, Kahneman admitted he completely underestimated COVID-19 exponentially and its consequences. If even he gets it wrong, are we essentially doomed? There's a link to a tweet that you can see if you want.
Very nice. Andrew, that's fabulous. You know what I'd like to point out here? He admitted that he underestimated it and that he updated. So he had his prior, he had new information, it surprised him, he updated his prior, he has his posterior, he told everyone about it. This is the way that it should work. So are we all doomed? No, as long as we follow his example and continue to do this, which is what I did myself when I was putting these numbers together and realizing that things are not quite as I had anticipated them.
Great, thanks, Jen. I'll let you know that using the car one is one that I use with family members that are a little bit paranoid. You know, like Ebola comes out and they're worried, so I tell them I sometimes use these examples myself. So all right, thanks again. So let's move on to our next talk.